The subject is the origin of life in the Earth. Here, how the life was born in the primitive Earth environment, and what the initial evolution are explained. How did the cell membrane of the first creature made? The cell membranes of most of the Earth's creatures have a long chain of hydrocarbons, which include carbon atoms of 16 or 18. Those molecules were floating on the water surface, as a liquid state in the early Earth. That is, the oxygen does not exist in the atmosphere of the primitive Earth. When the temperature of the seawater is high, the carbon dioxide does not dissolve in the seawater. So, hydrogen ions, a high-energy solar wind, collide with carbon dioxide, and the molecules are ionized to produce hydrocarbons. As the hydrocarbon molecules with a small number of carbon evaporates at the surface temperature of the early Earth, those molecules remain in the sky and continue to react. The molecules of C16H34 and C18H38 are liquid state at wide temperature range. The long chain of hydrocarbon molecules with a large temperature range in the liquid state have a strong intermolecular bond, and form the membrane by the hydrophobic coupling on the water surface. The hydrocarbons with a carbon number of more than 18 exist as a solid. On the other hand, C14H30 is not contained in the cell membrane. Its boiling point is 257 centigrade. So, it is estimated that the maximum temperature of seawater had reached up to 270 centigrade. How did the primitive Earth's H2O and CO2 come from? H2O and CO2 in the universe exist as small particle of solid. The smaller particle, the stronger intermolecular force. The small particles were collected by the accretion. The most of H2O and CO2, which covered the early Earth, were come from the crust by degassing. Those were emitted from the crust at the high temperature time, when large amounts of meteorites fell on the Earth. Also, it was released from the crust as a volcanic gas. The amount of hydrogen ions that sent by solar wind to the Earth is estimated by the ratio of the cross-section of the Earth and the surface area of the sphere, which is the distance to a position of the Earth centering on the Sun. The amount of hydrogen ions 10 to the 9th power kilograms per second is emitted from the Sun. Ignoring the effects of geomagnetic field, the amount of hydrogen ions that reach the primitive Earth in the solar wind becomes 39.3 tons a day, and in 10,000 years the amount of hydrogen ions is more than 10 to the 11th kilograms. The origin of life was a molecular organization by intermolecular bonds. The creatures maintain their lives by metabolism. The metabolism is achieved by the organization of the intermolecular bond, where atom can replace neighboring atom. The organization of intermolecular bond can be repaired by the reaction formed even if it begins to break. In addition, the organization of intermolecular bonding can be duplicated by the reaction that formed it. The creature was born by the molecular organization, which can replace neighboring atoms by thermal motion like a liquid. How was the first protein made? Some hydrocarbon molecules floating in the water have molecules that replace the hydrogen at the end with a carboxyl group. Since the end of carboxyl group is heavy, the carboxyl group side becomes the underwater side. Basic ammonia in seawater is adhered near to carboxylic acid, and amino acids are produced at the membrane surface. Amino acids have an ability to make a peptide bond with another amino acid. The protein was formed as if it sewed the hydrocarbon membrane. So, the structure protein was generated earlier time than RNA. The process that evolved from the floating membrane structure to the cell membrane is shown in Figure 4. Hydrogen ions collide with the surface of the water. The collision resulted hydrogen ion and hydroxyl groups. While the hydrogen ions became gas in the atmosphere, the hydroxyl groups were remained in the water. A hydrogen atom and a hydrocarbon on the membrane surfaces can be substituted with hydroxyl group. So, the carbohydrates were formed. Among the various carbohydrates molecules on the surface, the annular glucose, that matches the stereostructure of the water, was existed on the surface of the membrane. How was the RNA framework made? The ring structure containing the oxygen of glucose is easy to connect the frame with the atoms of the surrounding water. The glucose can be changed to a ribose. In the ribose, a carbon term is excluded from the ring of glucose. On the other hand, the phosphoric acid is a tetrahedral structure and phosphoric acid are abundant in the seawater. If three of the tetrahedral-shaped combined orbits are lined up at the interface, the remaining orbits are obliquely skewed to the plane. The frame of the nucleic acid of the spiral structure is formed as follows. The hydroxyl group of the ribose is substituted with phosphoric acid. The phosphate is formed by dehydration bond with the side chain of the molecule. How is the spiral structure of H2O made? Figure 7 shows a spiral arrangement of H2O in the liquid state. The tetrahedral molecules of water in the liquid state are connected by hydrogen bonds. Each molecule of the water has electric dipole moment. Linearly aligned, the electric dipole moments are arranged along a 3-revolution symmetrical electrical axis, and those tetrahedral molecules are connected by hydrogen bond. So, a spiral structure is formed. The life of the spiral structure is very short by the thermal motion. How was the codon of password born? The RNA of the spiral structure is separated from the membrane and becomes a messenger RNA. The long protein molecules that are synthesized on the backside that synthesize the m-RNA are separated from the membrane because the peptide bond is stronger than the hydrophobic coupling of the membrane. The parts of the membrane with traces of m-RNA and protein molecules are also released in the separation of amino acids because of the weak hydrophobic coupling. The fragments of the membrane evolved into transfer RNA. By combining the emitted m-RNA and t-RNA, the protein can be synthesized. The matching between m-RNA and t-RNA can be matched by the common work if the segmentation of references is the same length. The codon, which plays the role of password, which connects m-RNA and t-RNA, was made by the combination of 3 of 4 kinds of bases. Because codon was born and evolved on the nucleic acid side, it is not possible to infer the nucleotide sequence of codon from the amino acid side. How did the amino acid of D body and the carbohydrate of L body be synthesized? By the environment of the swirling movement by tetrahedral water molecule, the direction of the synthesis of the m-RNA and the direction of the synthesis of protein will be reversed. Therefore, if the carbohydrate of D body is synthesized, the protein is synthesized by the amino acids of L body at the other side of the membrane. The control of synthesis of initial protein by the initial RNA. There is a flow of the metabolism from the outside to the inside in the membrane. The m-RNA is synthesized at the surface of the membrane, and the protein is made in the opposite side of the surface. So, the synthesis of initial protein is followed by initial RNA owing to the flow of metabolism. How did the division of labor begin in a cell? Biochemical reactions are carried out by the release of molecules in a local area with specific reactions. When the catalytic reaction is repeated, it changes to make it easier for the reaction to occur. There are many kinds of work. Therefore, the partition between different reactions will be formed. Thus, the cells evolved through the improvement of the division of labor. The organisms evolved by doing activities. That is, how evolution works. The creature changes the ecosystem, because it is the existence of activities. The creatures evolve through a new trial and error by existing organizations. New features are added to existing organizations, and obsolete features will eventually disappear. There are times when organisms evolve dramatically with changes in the environment. The change of the gene system is realized at the time when a specific function develops rapidly. The mutation in evolution is an explanation of the change from the viewpoint of a long-term scale. Thank you for your attention.